All right, this strategy for working with trigonometric identities is to multiply by the conjugate. So you'll remember hopefully the conjugate from earlier in our distance learning. So if you have something like x plus y, just going to start with algebra before we get into the trigonometry, x plus y, you'll remember that the conjugate has the same two terms, x and y, but instead of addition, we have subtraction. So we'd have x minus y. The reason we like to use the conjugate, we used it for square roots so that we could get rid of the radicals. But what we're going to do with it here will become clear by the end of the video. But let's just see what happens. When we multiply two of these conjugates together, maybe you recognize this as the difference of two squares. But when you use the distributive property, x times x gives you x squared. And then you have plus xy minus xy minus y squared. So the reason that we like the conjugate and the reason we don't have to do this every time is because whenever you have a conjugate, whenever you have two of the same term, plus here, minus here, this middle xy and this negative xy are always going to add up to 0. So you'll always be left with x squared minus y squared. That's really great so that you don't have to do all this work. When you see that these are conjugates, you know that you just have x squared minus y squared. As long as, of course, these are the same terms and these signs are opposite. All right, that's going to be a great strategy when we get into trigonometry because we like to have things that are squared so that we can work with our fundamental Pythagorean identities. Okay, so a lot of the times if we need to get rid of a 1, all right, or if we need to be able to add things together, we want it to be squared so we can use the Pythagorean identities. So looking at this problem, we can see that we have this 1 plus sine x over here. We have this 1 minus sine x over here. We can't really add or subtract anything because they're not squared. It would make our lives a lot easier if things were squared. So in this case, I would say both sides are pretty equally difficult. I don't know if it makes a big difference which side you work on. I'm going to work on the left-hand side just because I'm more inclined to go to the left, not because it actually does anything. Another way I would think about this, well, let me show you what I'm going to do first. So looking at this function, I have cosine x over 1 plus sine x. So what I'm going to do here is I'm going to multiply by the conjugate. Now, in this case, it does happen to be the denominator. If I had been working on the right-hand side, I would have multiplied by the conjugate of the numerator. So it's not the conjugate just because it's in the denominator. Now, just like we did when we worked with the radicals, whatever we do in the denominator, do the same thing, numerator, denominator, multiply by 1. Hopefully we're pretty used to that by now. Another way to look at this strategy is, another way to think about it, is there was no 1 minus sine x over here. So in order to get it, I don't have it, I'm just going to multiply by it. I'm just going to bring it, I'm going to introduce it to the problem, to the left-hand side. And then I'm just kind of going to see what happens from there. So I'm still wondering if this is going to work out over here. Okay, so that first step, like I said, all I did was multiply by the conjugate. Now I'm going to multiply my two fractions here. So let's not forget that these are kind of all meet in parentheses, okay? And notice what we have in our denominator is what we were looking for, that conjugate. So I'm not going to distribute in the numerator because I need a 1 minus sine x in the numerator on the right-hand side. So I don't want to distribute that. It's here. I don't want it to go anywhere. I don't want to get rid of it. So I'm just going to leave it, and I'm going to hope that something's going to work out to get rid of that cosine x. Okay, it's not wrong to distribute, but then what you're looking for, what you need, is going to disappear. So you might as well just leave it. Now, looking at our denominator, 1 plus sine x over 1 minus sine x. I could do all the long steps and multiply it out, but I know that I'm just going to be left with the first term squared minus the last term squared. So I'm going to take the first term, 1 times 1, and I'm going to get 1. And the second term, or the last term, sine, is going to be minus sine squared x. So again, part of this strategy was that I wanted to be able to use my fundamental Pythagorean identities. So in order to use those, I needed things to be squared. So when I just had 1 plus sign, 1 minus sign, I couldn't use the fundamental Pythagorean identity. But now that I have 1 minus sine squared, that's equal to cosine squared. So in my denominator, I can replace 1 minus sine squared with cosine squared. So my numerator is cosine x times 1 minus sine x. Again, I'm just leaving it that way because I have what I want, so I don't want to get rid of that. My denominator now is going to be cosine squared x. And I've gotten a little bit lazy here, but these, of course, all are just the right-hand side continues to just be 1 minus sine x over cosine x. Okay, hopefully we're starting to see the right-hand side emerge in this problem. So now, what's in my way? I have this extra cosine here, I have a cosine squared here. Oh, well, it turns out cosine squared is just cosine times cosine, right? So I have cosine x in the numerator times 1 minus sine x. And then I have cosine x times cosine x in the denominator. And beautiful, exactly what I want to have happen. I have cosine x over cosine x, which makes a giant 1. And now my left-hand side is equal to my right-hand side. Okay, this is a strategy or a problem where you could have done either side of the problem. Picking the left-hand side versus the right-hand side didn't make a difference. And just once again, using the conjugate, so we like to multiply by the conjugate when we have addition, when we have ones and signs, but we can't use the Pythagorean identities because they're not squared. So multiplying 1 plus sign times 1 minus sign allows us to then use the Pythagorean identity.